Hello everyone, so in this video we have to write the appropriate Lewis structure for a species of H3C+. So first we have to determine the total number of valence electrons that correspond to the given formula. And then we need to, of course, subtract the one valence electron from the positive charge, or for the positive charge, because we have a cation in our case, so we have one less valence electron. Alright, so starting off with our protons then, our hydrogens, we have a total of 3 hydrogens in our molecule. So each hydrogen of oxygen provides us one valence electron. So 3 times 1 is equal to 3. So we get a total of 3 valence electrons coming out of our cation here. Then for our carbon atoms, we see that we have only one carbon of atom, and that one carbon of atom gives us 4 valence electrons. So then 1 times 4 is equal to 4. So adding those two up to get this total sum of valence electrons from our molecule, 3 plus 4 is equal to 7. So we have 7 total valence electrons. Of course, we need to remember that we have to subtract one valence electron since we have a cation here. So 7 minus 1 is equal to 6. So in our ion, we have a total of 6 valence electrons. So now we can go ahead and draw the atom with the highest bond preference in the middle, so carbon atom in our case, and propose a sigma bond framework. So sigma bond framework is just a connectivity of all of our bonds, or all of our atoms, in our molecule with just a single bond, hence the word or name sigma bond framework. Alright, so again we have our central carbon here connected to 3 hydrogens. And then we can see here we already have 3 bonds, and that's going to be a total of 6 valence electrons, and that's how many we have in our molecule. So now we have to go ahead and determine the formal charge of our atoms in the formula. So usually when a atom in the molecule does have a missing octet, that's a hint that it might have a formal charge. So our carbon atom in our case is going to be that atom that does not have a complete octet. So our formula for calculating for formal charge, we'll just simplify formal charge to be Fc. That's going to equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. We can see here if we use this equation here to calculate the formal charge for carbon, we can see that carbon will have a formal charge of +1, and it does match up with our species given to us in the problem, which is H3C+. We do need to keep this charge as well in our structure. So then my final answer is going to be this drawing out Lewis structure there with a +1 formal charge on our carbon atom. Again, we have a central carbon connected to 3 protons or 3 hydrogens with a single bond, and then this single carbon here will get a +1 formal charge because it does not have a complete octet.